right, morning everyone. Is everyone hearing me? You're hearing me, right?
Good morning. We're hearing you clearly.
Good. All right, so we have the registration form up, and then as well as my video is up. But yeah, so this is our CSEC student workshop statistics, and this session will be on, well, statistics part one, of course. So we'll have a part two later down, well, not later down this year, but later down in academic year, which is about in February or thereabout. But again, this is why we collected your information or data in order to garner such communications with you in the near future. All right. So let's start. So the registration form was sent in the chat and it's on the screen right now. So you can actually register for today's session. So far, I've seen 17 persons register, and we have at least 55 persons in the session right now that are participating as students. All right, so we want to get that out of the way. So I'll give about 1 more minute before we continue with this session. So the session should go up until about 12 o'clock, or in other words, we call it noon. All right. So you have 44 seconds remaining while I wait. All right, let's go. So that should have given enough persons time. 37 persons would have registered so far. So keep it up. So let's move. All right. So again, this is a CSEC workshop on statistics, and this is part one. So items you will be needing for this session. So you'll be needing a calculator because we'll do some form of calculation, and let's see how well we can actually put those data or information into our calculators and use it appropriately. You need a pencil or pen, a notebook. If you have leaves of blank papers, etc., that's fine. As long as you staple them together and have them as your what we call it, information bank or even question banks once we get onto those questions. All right. Is everybody with me so far? You can give me a thumbs up, or you can just say yes, sir, no, sir, etc. You can type in the chat.
Yes, sir.
All right, cool. And I am seeing some familiar faces. So from yesterday, and Bartley from KTHS, Kingston Tech. Good to see you. I think I've seen you in the matrices session. So accommodations to you. All right. So on today's workshop, we want to focus on construct a, what you call it, a frequency table. Yeah, I mean, you might be accustomed to seeing frequency table. So we'll be constructing frequency tables for the given sets of data. And next thing that we want to look at is the class features. So in this data set, we have some class features that are significant in answering some of these questions that you see, whether on the past paper or on the paper that you will be doing in the near future, whether it be this year, next year or the following year, etc. Determine the measures of central tendency for ungroup and group data. And lastly, we're going to look at standard deviation, how we interpret standard deviation, and in other words, how do we compare it to another value. All right, and we'll get shortly into that. All right, so you want the registration link to be sent again. So here it is. All right, that's it. All right. So we have a little icebreaker session. So this icebreaker, you'll be using quizzes. All right. So it's 7 questions. Well, it's not quizzes again, it's Wayground. But you'll be given 7 questions. And then, yeah, Campbell. So you'll be given 7 questions, and then we will go from there. So let me get that up for you all. All right, it's loading up. All right, so I'll be sending the link in the chat for you to use as well. Is everyone seeing the link? the game icebreaker thing loading up?
Yes, sir.
All right, cool. I'm gonna send it in the chat right now. So that's the link for the game. 7 questions, shouldn't take us long. I would say 7 minutes tops. And I have so far 65 individuals that are 67 individuals that should be participating. So let's see. I have 4 already. I see Steady in, Campbell, Russell, etc. All right. I need at least 30 persons to be in. Technically a little under the half, but let's see how that goes. All right, keep them coming. I'm seeing 11 persons so far. Okay. 12, 14. So I'm giving 30 more seconds before we start. Hurry up, everyone. You want everyone to participate as much as possible because your internet might kick off at any moment. And we want you to get at least something from today's session. Okay, I'm going to start right now. Good luck, everyone.
Good morning, everyone. Mr. Limit, could you repaste the link in the chat? There are some new persons.
So we have 5 more minutes, everyone.
Could you repaste again? Some more new persons.
All right, 2 minutes and 28 seconds remaining. All right, 30 seconds remaining. All right, I'll have to stop now, everyone. So I will have to stop. Sorry about that. All right, so that is our little icebreaker. So before we continue, let's review some of the questions that would have given some individuals a bit of a problem. All right, so the first one that we have right here on the screen. Let me just zoom in. What did we all select for this answer? What? Greatest number of employees. How do you know though that is and should be the correct answer? So everyone is saying, how do you can open my mind. Can anybody tell me? Why is it 44? Sorry, 44 to 54. Why is it so? Can anyone tell me? Okay. All right. So this is a chart that we generally use. Okay. So compare everything and see which one of them has the greatest value. Greatest value meaning, what are we actually looking for? We're looking for the tallest stack or the tallest bar, right?
Tallest
so the tallest bar. Exactly. So the tallest bar, that's what we're looking at. All right. So the tallest bar would have indicated 44 to 54. Can anybody tell me how much that would read? The number of employees? Can anybody tell me how much that would have been?
550.
550.
All right, how you know it's 550? 550, I should say.
Because they're in between 500 and 600.
All right, so it's literally halfway there from between 500 and 600, halfway. All right, so 43 persons got that question right out of 45. Okay, what about this one? Remember, it is always important to have a title for any graph table you're doing, especially when you're doing an SBA. You want to be consistent with that, all right? Because that is actually a mark that you can get, or you should be getting in your SBAs when you're doing it, all right? All right, so you chose B, all right. Why did you choose B? Why did you choose B? Why did you say type of fertilizer? Does that depict the Y and the X axis of this chart that you're seeing right now? And why you selected D? You have to give me a reason. You can't just give me an answer like that. I asked for a reason, justification, quickly. So B, type of fertilizers. C, the effect of plant height on fertilizer. And then D, the effect of fertilizer on plant heights. All right. So which one is it? It's only talking about fertilizer. You sure? What about that little axis over here on the y-axis, the vertical one? It says average plant height in centimeters. So which one should it be? Most persons are selecting D. Why D? You sure that's a correct title? Read it out. The effect of plant height on fertilizers. Is it the plant height that is being affected by the fertilizer? Or is it the fertilizer affecting the plant's height? Which one do you think?
It's the fertilizer affecting the plant height because the types of fertilizers, based on the number, it's telling you how high the plant would be when affected by the fertilizer.
All right. All right. Cool. I'll have to move a bit quicker, sorry. All right, how about this one? How many more people prefer purple as their favorite color than red? How do you know that this is B, Campbell? Jean Campbell, you said B? How do you know it's B?
So I subtracted the number. So so purple is 17.
All right, and it's halfway from 16 and 18. Yeah, that's why it's a 17, right?
Yeah, and red is 12. So I take away 17 from 12 and I get 5, which is the answer.
Well, it's actually 12 from 17. All right? That's how we actually should say it. Or we can say 17 minus 12, right? So when you say 17 from 12, it's actually the opposite. And that's really algebra or equations. All right, let me see which one. All right, how about this one? This is the last one before I continue. How many people took the survey? Or how many persons did the survey? We're at question 6 on the screen that you're seeing. No. Let's see, 100, right? How did you get the 100? How did we get the 100? What did we do to get 100? Add up all the numbers. Okay, vanilla. How much was it for vanilla? Vanilla, 24. How much was it for chocolate? 24 plus 26 gives us what? 24 plus 26 gives us?
50.
All right. And then 12 added to 50 gives us what? Which is for strawberry, sorry. 62. And what about mint? How much is mint? 22. So 62 plus 22 is how much? Is berry? How much was that? All right. And that's how we get the 100. So 16 added to 84. And that's how we get the 100. All right. So just quickly piggybacking on this one, I never actually gave the answer because some persons were saying that it is going to be D. Is it D or is it C? And someone would have justified that, but I never got the actual answer to say whether it's C or D. So remember that the person had indicated that the type of fertilizer is going to what? Affect the what? The plant's height. All right? So is it the effect of the plant height on the fertilizers? Come on, everyone. Does that logically make sense? The effect of plant height on fertilizer.
No, sir.
No. So what is the closest? But these out of it, it doesn't make any sense English language like wise. So the effect of the fertilizer on the plant's height, and that is C, right? Remember the individual that I've said earlier, the young man, he said that the fertilizer will have, the effect of the fertilizer will have some effect on the plant height, etc. All right? So I think most persons would have gotten this technically incorrect. Yeah, I'm seeing that so far. So that's onto frequency tables. So you want to construct frequency tables of a given set of data. Go ahead. My colleague would like to say something. I might have made an error. So go ahead. Go ahead, quickly.
No, I was just saying that it's D, sir, because D was the one that D actually says the effect of fertilizer on plant height. C has it the other way around.
Oh, my bad. Sorry about that one. Thanks. Sorry. Thanks for that catch. This is the count of how often something happens in a given set of data, right? So when we're making our frequency table, we want to make sure that we make reference to our frequency. So again, this is a count of how often something happens in a given data set. So what do you know about a frequency table though? Can you tell me things that you might find in a frequency table? Anything that comes to mind, right? Have you might frequency table primary or prep school, and even in your earlier years at high school. So what do you think a frequency table? Okay, it has a tally. Anything else? Anything else? A frequency table. So anything else that it would have or might have? Tally and FX. What is FX? All right. So a frequency table. Some function. All right. Well, this is not technically relation functions and graph, but statistics in a sense. But anyways, we can always inform that when we go on. So a frequency table organizes some form of raw data that are more Can anybody give me their opinion on what they think data?
I'm trying. Mr. Lima, you're going in and out and we're not seeing what you're sharing, if you're sharing.
Oh, you're not seeing my stream?
We're seeing your screen now. Yes, you're back.
What about now? You seeing it now?
Still seeing you and hearing you. Very good.
Oh, you're still seeing me, but yeah, okay. What about now? You're
Seeing
seeing
and
what is
hearing
data?
you.
Okay.
Yeah, yes, I see that on the screen.
All right. So I was asking for the opinions. What do you think data is to you? What does data mean to you? Can anybody give me their little opinion? All right. Can anyone give me their opinion on that matter? Data? No? All right. So data is a collection of facts such as numbers. Okay, a collection of information. Let's see. All right, data is raw materials collected information to be processed. Sorry, my thing was probably lagging. All right, cool. So data is a collection of facts such as numbers, words, measurements, observations, or just description of things, right? So we have some classifications of data. And you might be doing, well, you should be doing this in your SBA, not might. You will be doing this in your SBA if you actually started SBA. Well, you should have started. But yeah, so data. We have two classifications of data. Can anyone tell me or inform me what do they think are the two types of data classification? Any takers? All right, you said group and ungroup data. All right, we'll get into that. But I was leaning towards getting what we call qualitative. All right, Beckford, yes, good, qualitative. And what would the other one be? What the other classification would be? Or the type, as some persons might call it. And quantitative. All right, cool. So in your SBA, whether it's math SBA, social study, economics, whatever it is, you will be having some form of qualitative or quantitative data. So qualitative. What does qualitative speak to? And using the English language, qualitative and quantitative. What comes to mind when you see those words written on a paper, you're writing them down? Qualitative versus quantitative. What comes to mind?
Sir, I
Quality
think
and
that
quantity.
So I think
Yeah.
qualitative would refer to the quality of something, and quantitative is the number, sir, how much it is.
All right. So quantity, and I see Jerome, thanks for that. Jamonte said quality and quantity, that's a common verses that we normally have. One is process, one is numerical, quantitative is quantity. All right, we're getting there. All right, and we have descriptive, which you learn more about when you're at college to some extent. All right. So when we say qualitative, yes, you're talking about the quality, but in general, this describes a subject that cannot be expressed in numbers. So when you see the words, a lot of words being used, and it has nothing to do with any numerical thing, then we say it's qualitative. So of a vehicle, the flavor of your favorite ice cream, the eye colors of different persons. While quantitative, as you're saying, numerical values, they can be expressed in numbers. So they must be quantified. All right. Now, in quantitative data, you have two types of quantitative data. We have discrete, and we also have continuous. So when we make mention of discrete, we say that it's separate, it's distinct, and we can count it. So when you see something of that nature, then you are describing discrete values, and then you're going to quantitative. All right. So quantitative has two types, discrete and continuous. So again, discrete, just think about it as, oh, I can count it. Or in other words, some persons might say, oh, I jump from one to another. And we generally use whole numbers. Most persons use whole numbers. While the continuous values, or continuous data, I should say, they don't have any gaps. And the key word that we generally use to remember what is continuous data is that they can be measured and not counted. So some examples, what can we measure? What do you measure? If you do any science-related subject, or if you even did integrated science or general science in lower school, what can you measure? What comes to mind? And I would have somewhat hinted at that in the icebreaker. What can we measure? What are some of the things that we can measure? Okay, the width of the football. Okay, football field, the weight. So we can measure the weight, the volume. And what about your height? You can measure your height. You can measure time, temperature. All right? So that is what we mean by, or that is what we signify continuous data as. All right, is everybody on the same page? Is that clear, fresh? Nice, lovely? Okay, all right, good, great. All right, so again, you learn more about statistics when you're at the college level. You'll do something called introductory statistics, and you'll dive more into that. So this is a foundation. So what you're doing in high school is your foundation that will set you apart when you go into that statistics class for your university or college sessions. Now, I know everybody was saying, oh, ungroup data. Well, I think one person said ungroup data and have a group data. Now, I have two images that I'm going to share right now. So we have the subheading being ungroup data and group data versus group data. Now, looking at these frequency tables, we're seeing the age on the left, the tally marks in that table, and frequency. And on the right side, we're seeing the right image, we're seeing class interval, tally marks, and frequency. All right? I mean, those are frequency tables, right? So can anyone tell me which one of these would be my ungrouped data? The table on the left or the table on the right?
The table on the left would be ungrouped.
Okay. Why do you think it's ungrouped?
Because it only has a specific range group.
Okay, it has a particular value all right, and it's not going from that place to that place, okay? And what about the one on the right? Is that still ungroup or is that now group data? And you still can answer, you can let someone else answer if you want. So go ahead. Any takers on this one? The one on the right side, the table on the right.
Sure.
Group data. So what makes it a group data? What specifically makes it a group?
Because it's showing a particular number from like age 1 to 10, level to 20.
Well, sorry to cut you. This isn't necessarily an age, but okay. 1 to 10 is just a class interval, right? I never actually gave it a title. So yeah, continue. So 1 to 10, right? That's a group, right?
Yes, sir. It's like it's grouping
Right?
the
All right.
numbers in a particular way, sir.
All right. So you're saying it have more numbers than the ungroup? Well, we'll speak about that in a short while. So the left being it only has one age for a person, while the one on the right is more group and can be a variety of numbers. So I like that part about it being the variety of numbers from, well, between 1 to 10. Well, 1, 2 to 10, not really necessarily between. All right. So frequency tables organize raw data in two ways, and we would have discussed that, which are ungrouped data and group data. Now, let's speak to the person who said it has more numbers than the ungroup. So when you look at the age on the left, the table on the left, we see 24, then 25, 26, 28, 29, 31, 33, 35, right? So would you say that those ages are close together or they are wide apart? Is it like narrow or is it wide? 24, 25, 26, 28, 29, 31, 33, 34. They're close together. So my question to you now, would I want to have this as a group data? I know it's ungroup data, but does it make any sense to put it in or place it as a group data? Let's say group data from 24 to 35. Would that make any sense? No. All right. So let's look at the group data. What are you noticing now about the class intervals? Are they narrow or are they wider? Are they narrow or wide? Sorry, my bad. All right, it's much wider. So it's not about necessarily the one that has the most numbers, right? It's technically finding what we call, I won't say the word yet, but using the narrow and the wide aspect of it. So that is how you can use the wide and the narrow aspect of this class interval or the age in order to determine whether you'll be using ungroup or group data. So we say when blank is narrow, you'll fill in the blanks later on. So when blank is narrow, there is no need to group the table. So this is why we have ungroup, which is one on the left side, the left table. So blank is said to be, I won't get that yet. So the grouping data, it starts at what? What does the grouping data start at and what does it end at? What number does it start at and what number does it end at?
1 and 100.
1 to 100. So that's very wide, right? So that one is wider. So it has a wider spread. So again, that's why it's grouped. Now onto the blank that I said. When the blank is narrow, there is no need to group. So the table is ungrouped. So what is that blank called? Can anybody tell me what that blank is called now? It's literally on the screen. No one? All right. Yeah, there's no much more for a gap. Yes, it's a range. So when the range is narrow, which you're seeing on the left, this is why we have ungrouped. And when it's wide, we have it as grouped. So what is range?
So
how wide a data set is? Yeah, go ahead.
So my data is like when it is grouped. Or
Repeat that
wide
one?
this is so like like it just show you like from 1 to 100, sir.
Yeah. So the wider it is, you'll have it as a group data, right? So range is what we call the difference between the lowest and the highest values in a data set. Now, do we see any specific term that would tell us what operation we will be doing with the highest and the lowest value? Do you see anything of that nature? Which term?
Difference.
Difference. So what does difference mean to us?
Subtraction.
Subtract. So tell me. So we'll have an equation, but just tell me from now. Would it be the lowest value from the highest value or the highest value from the lowest value? Just saying it verbally or orally.
From the lowest value.
Highest value from the lowest value.
All right, let's see. So the lowest from the highest, all right? So again, it's very key for us to have that discourse, that math language, so we don't misinterpret what the question is saying or what the equation or the formula is giving us, all right? So I know you're seeing it on the screen and you might say, oh, it's the highest from the lowest, right? But technically speaking, that's a different equation, all right? So again, it's very important to make sure you understand this math language. Just like how you have English language and we talk, you might talk in standard English at times and patois. That's a rule and we follow it and all of that. So we have math language, we have math rules that we need to follow. We can't go around them, all right? When you go around them, you'll have more problems in the near future, especially when you go to college, right? So you can take this image off, by the way, I forgot to say that. So range, highest value minus the lowest value. All right, the lowest value from the highest value. All right. So we have some raw data from this survey that we did, right? And it technically, yeah, we somewhat did this. All right. So we have some, so when you're doing your statistics part of your SBA or your data collection, or you're analyzing the data, and you want to put it in a table, you now use a frequency table, and then you get onto the graphs or the charts, etc. So raw data from a survey that was conducted on students to find out how many siblings they have. So we have 3, 0. So reading from left to right, everyone. 3, 0, 1, 4, 4, 1, 2, 0, 2, 2, 0, 2, 0, 1, 3, 1,
2, 1, 1, 3.
All right, big up yourself. All right, so those are the values that we have. And I might have sounded like a recording, but yeah. So those are the values that we have. Now, we want to calculate the data. So what do we analyze first? What do we take from the data set that we have?
Sir,
highest from the
group
lowest.
them, sir.
Well, we're not ready for the grouping yet. But remember that the range is how the discretion of how wide our how wide or not the data is.
So you find the largest
Look,
number
the
from
lowest
the
number and highest number, sir.
All right. So what is the lowest? What is the lowest value? 1, you sure?
0,
Zero,
sir.
sir.
Oh, we see 0. When I think about 0 as anything important, well, 0 is a part of mathematics. It's important. It doesn't necessarily mean, yeah, nothing. Nothing, I don't write anything. I have to write 0 to signify that it means you have that value. It means something. So 0 is the lowest value. What about the highest value?
4.
4, sir. 4.
So what is our range? What is our range?
4.
0 to 4.
0 to 4.
0 to 4.
All right. You notice how I said it now. What is our range? You'd have said, okay, 0 to 4. That's if we're putting it in if we wanted, but we're not going, well, let me not say that yet. So we're finding the range again, the highest value minus the lowest value. So the range is not 0 to 4. The range is going to be what? Just 4. All right?
Well, 0 is like a non-number, sir.
So the range is 4. So when you say 0 to 4, you might be confusing it with what we call the class interval. All right? So again, you see going around these terms in mathematics would lead you astray. Yeah, you want to make sure you have the foundation proper and it's set. All right? So when you have a good foundation, the base of your arm can crumble to some extent. All right? So range is 4, not 0 to 4. All right? Is everybody clear with that?
Yes, sir.
All right.
Yes, sir.
So let's see. Let's see what happens now. So, all right. The question now, how would you organize this data in a frequency table? Are you going to have it as a grouped frequency table? Or you're going to have it as an ungrouped frequency table? And I want you to justify your reason. All right, so where's the ungroup for now? I see one person saying ungroup. Anybody else? Yeah, group. All right, cool. Well, it's not groups, it's actually grouped, okay?
Sir,
Put
it's
on the
too
email.
narrow to
Ungroup,
be
sir.
grouped.
Ungroup.
It can't be grouped.
All right, so I like that. So he said he's using the terms that we would have mentioned, right? It's narrow, it's too narrow, right? From 0 to 4. Would I waste my rows and columns and etc. and my titles just to write 0 to 4 and just write it everything right there? No, I don't want to do that. So it's called what? We'll get more into that. But
ungroup.
All right, let's see. Do I have all of us saying ungroup, or we're still caught on the group right now? Grouped data.
Ungroup, sir. Because
All right, big up yourself, Alexander.
Yeah.
All right, yeah, I think you changed. No, Nicole, I think you changed it from the groups to the ungroup. So you're seeing that little clarification, and you're seeing where it is an ungroup data frequency table that you'll be using. Now, you would have seen the tables for our group data and ungroup data, right? So,
yes, sir.
We're going to create our own, you know. We're going to show you how to create it. All right. So, how do we create a frequency table for ungroup data? Now, step 1, yeah. Just like when you watch TikTok and you hear step 1, do this, step 2, do that. Yeah, we're following this trend. So, step 1, make 3 columns. What are columns again? How do we describe columns? And if you were in that matrices session, the 2 sessions, you would have known what is a column. But yeah, what is a column? How would I describe a column in layman's terms?
Vertical series of data.
Okay, vertical. You're using those big words with me, series and etc. So make 3 columns. The first column carries the data values in either ascending order from small to great, all right, small to large, etc. So can anybody tell me what is my first column's name? What is the title of my first column?
Number of pets.
Number of pets. So that's my column. And is it arranged in any specific order? Is it all over the place?
No, sir.
No,
and what
sir.
do you see? You see 1, 2, 3. All right. So I have my smallest value, then going to my larger value at the bottom. And you can rearrange it still, but you want it to be in either ascending order or descending order. All right.
Yes.
And I know you see the other 2 columns, which we'll disclose in a few. So that's step 1. We have our 3 columns. How many rows do we have? Let's see. Let's see who is thinking. How much? 3? You sure?
3.
No,
4.
4.
I have 4 rows and 3 columns. And let's see if anybody remembers anything about matrices. What is the order? Technically, I can't really say this, but what is the order of this table? How many rows, how many columns? 4 by what?
4 by 3.
4 by 3. All right, good, fantastic. All right, cool, nice. So step 2, our second column. What is our title for the second column that we had earlier?
Tally.
It's a tally. So what is a tally now? This is where, when we have the number of pets, we're going to see how many persons like or have this number of pets, which is 1. So let's see what my tally is. What is my tally?
3, sir.
3. All right, so I have 3 vertical what you call
lines,
it?
Sir.
Lines.
Sure.
All right.
Yes, sir.
All right. What about the number of pets? 2.
2, sir. 2, sir.
Okay, I literally have 2 for that. I don't know why. All right. What about this one?
6. No, 5. 5. Sorry, 5.
Which one? 6 or 5?
5, sir. 5,
5,
sir.
sir.
Right. So you see the 4 strokes, as in 4 strokes vertically, and then you see that little one that will chop it diagonally. Well, at the gate, right? We're not gatekeeping, right? So we're going back. All right. So technically it's a gate. We'll lock the gate, but yeah, we're not gatekeeping though. All right. We want you to learn as much as possible. You tie the bundles. So this is why you have that. The other one saying that this signifies that we have 5 in this tally. All right. Let me just go back for the person who asked. So this is the first one. All right. Janique, go ahead. Do your thing. Tell me when you're ready. Okay, good. Fantastic. Lovely. All right, cool.
Please.
Oh, you want I mean, you can take this, but all right, go ahead. That's cool?
Yes, sir.
All right. All right, so step 3, count the number of tally marks for each data value and write it in the third column. Was the title for the third column? Let me just put it back. Title for third column.
Third, the logo up, sir.
Oh, repeat that one.
Never mind, sir. But
What was the title?
We can go and talk, sir.
Oh, sorry. Yeah.
Yes, sir.
All right, so what is the title of the third column? Frequency.
Frequency,
right?
frequency.
All right, sorry about that. My apologies. Okay. All right, what about the other frequency for the number of pets? What will be the frequency for 2 pets?
2, sir.
All right, so I have my 2. And you notice I'm using numerical values and I'm not using any vertical strokes or whatever. So I continue. All right, and the last one is 5, as I would have mentioned earlier. And remember that this recording or this session will be on YouTube as well. All right, so you can always check out the channel to see if you missed any other videos. Missed any other sessions, the topics, and you can review at your own leisure. All right?
Question, sir.
Yeah, go ahead.
What's the YouTube channel?
Oh, the YouTube channel, it is, let me just get that for you.
I'm about to share it, sir.
All right, good, fantastic, thanks. So the solution, I mean, it said, would you put it in a group or ungroup, and we said ungroup, right? So let's now have our frequency table. So the number of siblings, how much do we have? How many number of siblings do we have in our data set? We have 0, 1, 2, 3, 4. And we have that in ascending order, right? So the first one, so you don't want to pick it out, as in you don't want to look at all of the zeros and then you put it in. That might confuse you when you actually calculate the amount of, the number of persons who did this survey. So we have 3. So that's the first thing that we're going to do. We have 3 in the data set, 3, 0, 1, 1, 4, etc. So let's go for 3. So the tally would be what? 1 for 3. So we have the 3 and we have the tally, right? We continue, 0, and we put it in our tally. We continue, 1, put it in our tally, and we continue, right? So we continue from left to right until we have reached our values. All right? Yes, 4. My bad. All right, so we're gonna do that quickly. All right, when I tie, sorry, not cross, or tie the bundle or lock the gate, I get 5. Okay, remember that. So what is my frequency for the number of siblings of 0? When I have no siblings,
4.
What is the frequency? 4.
4.
All right.
4.
When I have 1 sibling, how many persons said I have 1 sibling? Not in this room, you know, but
6.
in this thing. 6. All right. And how many persons said I had 2?
5.
Number of siblings.
5.
All right. Remember, this is not in your actual life. This is a data set that you're using. So don't make it too real. All right. And we have 3 for the number of siblings to be 3.
2.
And we have 2. Now, what if I asked you how many students or how many persons did this survey? What would you tell me? How would I find that value? How would I find out how much persons did this survey?
FX.
So you gotta add all the number
Number
of
of
people
frequency.
that answer the question of number of siblings.
Repeat that one.
You add everything in frequency, sir, until equal.
Yes. So this thing about FX, you have to watch that one, you know. All right. We haven't reached that stage yet. So to check, you will add up all of those values. All right. So the 4, the 6, the 5, the 3, and the 2. Can you tell me what that value is? Can you tell me how many persons did it?
20, sir.
How many?
20.
20. So 4 plus 6, 10. 10 plus 5, 15, plus 3, 18, plus 2, and that's 20. A whopping 20 persons did that survey. Now, calculating the range for this data set that we have, and I'm going to bring it up shortly. So we have the length of 36 students, sorry, 36 students.
Oh.
Okay, range.
Sir, it along, sir.
50.
You notice I said how to calculate it. I never asked for any final answer. How do we calculate range?
So we're
The
smallest
highest
number.
take
The
away the
highest
value take away the lowest value.
Okay. All right. So what is the highest value?
58.
58.
58.
And what is the lowest value?
9.
8, sir.
8.
Who said 9? Look at the data set again. It's 8. All right. So the highest value is 58. The lowest value is 8. Right? So to find the range, we have 58 minus 8. In other words, 8 from 58, which gives us a 50 as what an individual would have said earlier. All right? Is everybody hearing me now?
Yes, sir.
Yes, sir.
All right, cool. So when you're not hearing me, just say, "Oh, lagging, sir," and I'll get it. All right?
Somebody
Yes,
did
sir.
say.
So I don't have to repeat myself so much. All right. All right. Now, would you create a group or ungroup frequency table for the data that you have on the left side of the
Group,
screen?
sir. Group.
Group, sir, group.
All right. So tell me why.
Because, sir,
Because
there's
the
no
range,
zero.
sir.
Because of the range.
Yeah,
What you know about the range? What you notice about the range?
There's no zero, sir.
No. What did we say about the range? The range is the
Zero coming here,
dispersion.
sir.
Sir, the fact that 8 is so far from 58, you can make a
Yes,
group set, sir.
exactly. The range is very wide, right? So this is
Yes,
why
sir.
you would have had a group data.
Yeah, a
All right?
group. Yes,
All
sir.
right, cool. And is everybody clear about constructing a frequency table? Whether group or
Yes, sir.
ungroup? All right, well, to that extent. All right, cool, nice. Love that for you all, as one of my colleagues would say. All right, so we have the class features. We're on to the class features, which is technically the second out of the second out of the 4 things that we want to cover today. So class features. We have a good amount of class features, and I'm not talking about your class and the features that you have in your class to make it different from anybody's class, but class features in statistics. So don't make this thing too real. All right? So how do we create a frequency table for group data? Remember, we would have highlighted the question before, and that is what we're going to use. And we said that it's going to be a group data. All right? So before we do all of that, before we do the group data, we need to find out all of these class features, which are class interval, class width, class limits, class boundaries, and the class midpoint. So all of these class are features, right, that we'll discuss, and then we can create our frequency. All right, have I gone somewhere? Okay, I'm still here. All right, nice. All right.
Sir.
So class in
Yeah, hear me, sir?
Yeah, I'm hearing you.
Yeah, well, I way that you did that break up, so whenever you hear say properly. Well, me.
Oh, I was asking if everybody's on the same page, technically speaking.
Yes, sir.
Is everybody good with this? All right, cool. Thanks again. So we have class intervals. Now, class intervals are the subsets into which the data is grouped. All right. So when we saw the class interval for the frequency, for the ungrouped data that was given to you, the image, we had 1 to 10, right? So that's our class interval, right? And then we continue until we get to 100.
Yes, sir.
So class intervals should not overlap. So one number belongs to only one group. So it can be what we call in a set intersection. You can't intersect, right? Your number is only in this group, and it can't go over into the other group. All right? So class intervals should exhaust all the values in the data. So whatever values you get, the lowest and the highest, they should all be in your class interval. Okay? And next thing that we generally highlight is that all class intervals, their width, yes, their width, or their size should be of the same. Their class interval width should be the same. All right? Is everybody cool with that?
Yes, sir.
This is technically some theory so far, and we actually get to the practical part of it right now. So we have the seedlings, the 36 student seedlings, right? So I have my class intervals. I want you now.
Go back for me, please.
Oh, go back to this one. All right, quickly, because I need to press on. And remember that this is on YouTube, so you can actually do it in your own time, right? All right, cool. Thanks. So the class intervals, we have 1 to 10, 11 to 20. And I want us to complete this table of class intervals. What would come after 11 to 20? Would I have, okay.
21 to 30.
All right. And you see, just like how they have that little, what do you call it? One of my colleagues, you can help me out with it. I think it's, what's this called again? The little thing between the 21 and the 30. I don't quite remember what it's called.
The dash,
little dash. Yes, I was going to say that one, you know? I wanted to make sure. That little dash. Make sure you have the dash. So you can't actually say 21 to 30. Yes, it's 21 to 30. The TO, the 2, right? You want to use the dash. So you want to be consistent with whatever they had started with, all right? So yes, 21 to 30 means that, but you don't want to write the word 2, TO. All right, so 11 to 20. What would the other one be?
31 to 40.
What would the class interval be after? Which one?
31 to 40.
All right, and, you know, I'm going to want you to write it, you know. Saying it, yes, saying it is perfect, fine. But I want you to write it in the chat. That will help me better to make sure that you're actually understanding what I'm trying to push, or what we're trying to push. So 31 to 40, all right? So yes, we say it in words, 31 to 40. You're using the word TO, but again, you want to make sure you have the correct values. All right, 31 to 40. What about the other one? What comes after 31 to 40 interval? Class interval, sorry. All right.
41 to 50.
Okay. And is it finished right now? Is the table complete?
No, sir.
51 to 60.
All right, 51 to 60. Do you notice anything now worthwhile? Do we have 60 in our data set though?
No, sir.
No.
So why we have 60?
So that'll be 51 too.
Sir, 51 to 58.
51 to 58.
But remember what was said earlier. Let me just go back for everyone. What was the last thing that was said? And it's emphasized, or it's in red. What did they say? The class interval width must be what? The same. So if we had 51 to 58, the width would not be the same, right? I don't know if you notice, but on the right side, I won't tell you what the right side is. But when you have 1 to 20, the 10 is on the right side. So 10, 20, 30, 40, 50, 60. You should be at least seeing that all of those numbers, you say you can add by 10 to some extent, right? And you can do the same thing for the left side, add by 10. So they are the same width. They must be the same width. So that's why I highlighted it. All right, everyone? So yes, it does stop at 58, but your class interval needs to be consistent and your class interval width must be the same. You can't have something different and expect to get the full marks. All right? So let's create a frequency table. And I've been on this, I've been saying that, but we're going to actually create it in a few. It might take a little longer than expected. All right, so we have our class intervals, 1 to 10, or tally. We're going to do our tally. So technically the second row, but the row of values that we need to find out. 1 to 10. What is the, let's go. So 9, we're going to start with 9, right? As in, we're starting from left to right and go down, instead of actually finding the numbers from 1 to 10. That makes it a bit more complex, all right? So we have what? Oh, yeah, we're going to go to the boundaries now. Don't worry about that. We're going to the boundaries in a few. All right?
Oh, the baby, bro, the baby. The baby.
All right, nice little baby. That's fine. All right, cool. All right, let's continue. So 9, the tally would be in which interval? The tally, the number 9, sorry, the length 9.
1 to 10, sir.
What class interval would it be? 1 to 10. All right, good. And we continue. You notice the stroke is there for the 9. And then now the 10, do the same thing. 13. I won't be able to do all of the strokes, but let's follow. So this is 13, then 15, 21, 35, 27, 26, 51, etc. We're just going to go until we're finished. All right? So I'm going from the top left and making my way down until I reach the last number, which is 42. All right? So everything is being filled in for us. But again, you have to do it manually. All right. So our first frequency for class interval of 1 to 10 is 5. What about our class interval of 11 to 20? What is that frequency?
6.
6. And what is the frequency of 21 to 30?
6.
6. All right, 6. 6 is such a number, yeah? Next one, 31 to 40.
6.
6. 41 to 50.
8.
8.
8. All right. 51 to 60.
5.
4.
Now, how do I make sure that the values that I have in this frequency or in this frequency table, they are correct? So I want to double check. I want to double check my frequency because I know that my tally is right because I went from left to right. I'm not searching for the numbers 1 to 10. That makes it a bit more difficult. Your eyes might confuse and, you know, you might see too much things that you're not supposed to see. So double check. So we have the frequencies. We're going to add the frequencies. So 5, 6, 6, another 6, 8, and 5. What does that give us? It gives us, Ronaldo said,
36, yeah.
36. 36. So we're seeing 36 Ronaldo. Is that how you pronounce the name? I would hope so. So 36. So that's how we double check.
36.
All right. Cool. Nice. So we always want to check to make sure that we have the right numbers. All right. And sometimes they don't give you the length of the 36 students. They won't say the 36. They just say the length of the students' seedlings. And then they'll ask, you know, how many persons did this survey or how many persons did this. All right. So this is how you also check. So class limits. So I would have somewhat mentioned class limits, but I never actually used the term class limits. So class limits may be referred or defined as the minimum value and the maximum value for the class interval. All right. So the minimum value is known as the lower class limit, and the maximum value is known as the upper class limit. Notice I have not said anything about boundaries yet. These are just the class limits. So they represent the minimum and the maximum value. So let's see. So I have my class intervals, and this is technically just a table that you can use to remember. All right. So what do I do next? What is the lower limit for the class interval of 1 to 10? What is the lower limit? What digit would be the lower limit for class interval 1 to 10? All right. So 1.
1.
Who said 9? What is the minimum value? The minimum value is 1. And yes, you might 1, but you might say that I don't see 1 over there, right? But this is just our class intervals to make sure that we have all of the numbers accounted for, right? So we have to have a class interval, right? So my class interval is 1 to 10. So that is what I am using. And it will be set almost the same on the CSEC paper. They will give you class intervals and you have to use them. You might not see the table or the heading saying class interval. You might see age, you might say mass of some, etc. Right? So you won't always see class interval, but you should know that the first column is generally something about the class interval. So the lower limit is 1. What is the upper limit for the class interval of 1 to 10? What is the upper limit?
10.
Remember, you're not, yes, for the class
Oh,
interval.
lower class, sorry,
notice?
sir, 1.
Yes, I said the lower class interval. All right, so that's 10.
Yes.
What about 11 to 20? What is the lower limit? The class interval, 11 to 20, what would be
11,
the
sir.
lower limit? 11. What would be the upper?
20.
20. What about 51 to 60? What would be my lower limit?
51, sir.
51. So just checking if everyone is listening. So 21 to 30? 21 to 30, what is my lower limit? All right, so that was the previous question. So now this question, 21 to 30, what is my lower limit?
21.
What is my upper limit?
30.
All right.
30.
What is my lower limit for 31 to 40?
31.
All right. And everybody, you see, you're getting the gist of it now, right?
Yes,
Yes, sir.
All right, so I can just fill in. All right, so these represents the lower limit and the upper limit, and they are important in finding future values that we need. All right, so on to the lovely class boundaries as was mentioned. So when you speak of class boundaries, I think someone mentioned it in the chat. Is it that you wanted to know if we're doing class boundaries or you know something of class boundaries? Do we know anything about class boundaries? How do you remember class boundaries when you're doing statistics? Okay, all right, cool. So let's make you understand. Not make you, but let's make sure that you understand. All right, so class boundaries are halfway points separating one class interval from another. So these are literally, just like we have a fence or a wall around your house, your perimeter fence, those are your boundaries or whatnot. So in statistics, we have boundaries to make sure that we don't go over into another class interval, right? Remember, you must exhaust all your values and such. So there are two boundaries. You have your upper boundary and your lower boundary. So there should be no gap between the upper boundary of one class interval and the lower boundary of our next class interval. So it must be continuous. You can't have 5 and then technically jump to a way bigger number, etc. It must be continuous and must have no gap. So let's look. Before we get to the actual class boundaries, we need to do class width. So class width tells the size of how many values are in the class interval. So we'd have mentioned the width a bit, but we have two different formulas that we can use to find the class width. So we have the lower limit 2 minus the lower limit 1, or we can use the upper class boundary and the lower class boundary. So this is why we did the lower limit, the class limits, and we just discussed the class boundaries because we'll be using it to find our class width, which is crucial in making sure that your points are exhausted. Is everyone hearing me? I'm not lagging.
No, sir. We're hearing you.
Sir.
Yeah, sir.
All right, cool. So you can use any one of these formulas to find, or equations, I should say, to find the class width. So you can just take a snippet right now, or write it down in your book quickly. All right. I'm going to give you a 5 second. 1, 2, 3, 4, 5. My 5 seconds goes so quickly. So verifying the class width using the lower limits. So we have our intervals 1 to 10 and 11 to 20. Now remember, you must be using, you have two out of 2 formulas, but we're using the lower limits. So it's lower limit 2 and lower limit 1. Now, can you identify the lower limit for this class? Sorry, the class, where is it? No.
1, sir.
For 1 to 10, what is the lower limit?
1, sir.
1.
One, sir.
Okay.
1.
All right. Using the other one now, the class interval that comes after.
11.
What is the lower limit for for 11 to 20?
11, sir.
11.
11. So I'm using both of those lower limits now, and then find the class width. So 1 and 11. Which one do you think is the lower limit 2 and the lower limit 1?
Lower limit 1.
Lower limit 1 is?
1, sir.
All right. And lower limit 2 is?
11.
All right. So it must be class intervals, the next class interval, right? You can't just say, oh, let me use 1 to 10 and find the lower limit for that. And let me use 31 to 40, find the lower limit for that. It has to be the next class interval. All right. So we identify our lower limit 2 as 11 and our lower limit 1 to be 1. So we subtract them to get the class width. And what is that value? 10. Now let's use the next class intervals. So we're using 11 to 20 and the 21 to 30. What is the lower limit 2? So again, we're using class interval 11 to 20 and 21 to 30. Again, it must be the next class interval. All right. So what is our lower limit 2? Which number would signify our lower limit 2 in the class intervals that I just mentioned? 2 class intervals that I mentioned. What would that be? Any suggestions? You can open the mic. Yes, speak. What's this? Speak. Okay. Go ahead. Oh, nothing? All right. So our lower limit 2 is going to be 21. Yes, Justin. So, and our lower limit 1 would be 11. So when we take 11 from 21, what do we get? 11
10.
from 21 is 10. So are you now seeing that we're getting the class width to be the same values? They must be the same value. So what would the other one be? What would be the lower limit 2 and lower limit 1 for the other two
lower
class?
limit 2 would be 31.
Yeah.
And lower limit 1 is 21.
All right. So we subtract and we get 10. We do the same thing and we get 10. So you now see if you had, well, technically, I can't really say that right now. But what would be the other class interval after 51 to 60? Just asking. What would be the other class interval after 51 to 60? What would that be?
61 to 70.
61 to?
61 to 70. 61 to
All
70.
right. Now, what you see, what if we had the 58, the 51 to 58, and we had the 61 to 70? We would not get the same class width, but the class width must be the same. All right. So that's using the lower limit. So you have two options: lower limit to find the class width, or you can use the class boundaries. Now let's speak to the class boundaries. So I have my lovely little table right here. So I have my class intervals, I have my lower boundaries and my upper boundaries. To find the lower boundaries, remember, I did say something about halfway. All right. So what do? I will have my lower limit value, which is 1, right? And I will subtract that by 0.5, which is my little halfway, right? So this is the lower boundary. So the lower boundary is using the lower limit in the class interval of 1 to 10, which is 1, and then subtract 0.5, right? And what is 1 minus 0.5? What do we get? What do we get? 0.5. All right. What do you think will happen to the upper class boundary now? What would I add together to give me my upper class boundary? So I did my lower. What would I do to get the upper boundary? Add 0.5 to what?
Sir.
To what?
Add 0.5 to the 10.
You just said 10.5 or 10? Which one? I can't hear.
10.5.
0.5.
0.5 to what?
10.5. 10.5.
Remember, is 10.5 your class interval in 1 to 10?
No, sir. So you go add 1 plus 0.5.
your upper limit. What is your upper limit for class interval 1 to 10?
10, sir.
Oh, 10,
10.
sir, 10.
So the
10.
10 you got add to the 0.5. So yes,
Oh,
careful. You add the 10.
add 0.5 to the 10.
11, sir.
So you see it now. How do we get? 10.5.
10,
Right?
sir. 10.5.
All right. Let's see if we can match up the lower boundaries for the second interval. 11 to 20. What calculation would I do to get my lower boundary? Somebody tell me. What calculation would I do to get my lower boundary?
11 minus 0.5.
All right. At it. What is that? What does that give you?
10.5.
All right. 10.5. Match up the upper boundaries now. What would I add? What calculation would I do now to get the upper class?
Yeah,
20 plus 0.5.
All right. Let's see the maths now. The maths are work. The
20.5.
maths are click now. Right? The maths are click and we get 20.5. Match
So
up the other one. Class interval 21 to 30. What would be my value for the lower boundary?
So yeah, minus 0.5.
21 minus 0.5.
All right, 21. And don't say what comes after 21. All right, 20.5. 30.
Add
30 plus
30 plus
0.5.
0.5.
All right, cool.
30.
All right, and we can do all of this, yeah? So
Yes,
make sure you use the calculator properly. All right? You need to check how and what you're using. All right, let's see. So those are lower boundaries and our upper boundaries. All right? Is that clear now for the two individuals I said that they said that they didn't understand? Katie and White?
Yes, sir. Yes, sir.
All right, you good now? All right.
Yes, sir.
All right, cool. So again, when you're finding the lower boundary, you're subtracting 0.5 from the lower limit. When you're finding the upper boundary, you're adding 0.5 to your upper limit. So that's why it's so important for you to understand the terms associated with these things in order to make sure that your foundation is solid as a rock. All right, I never did the last one. Now the boundaries. Using the class boundaries to find the class width. So I have my lower boundary and my upper boundary. Remember that we said, what would be the class width? How do we find the class width? When we're using the boundaries, what operation will we be doing with the two boundaries? Are we adding, subtracting? What are we doing?
Subtracting.
Subtracting. So what are we subtracting? We're subtracting 10.5, well, 0.5 from the 10.5. So the 0.5 is a lower class, is a lower boundary, and the upper boundary is 10.5. So that's how we get 10, right? And when we do the others, 20.5 minus 10.5, that gives you 10, right? So are we seeing that we get 10 for all of them?
Yes, sir.
Are we all seeing that?
Yes, sir.
Yes.
So our class width is 10. So whether you use the class limits or the class boundaries, you will get the same value for your class width. Is that clear as a sunny day or a blue sunny sky day? Why did I say that? All right, is everybody clear with that?
Yes, sir.
All right, cool.
Yes, sir.
0.5.
All right, class midpoint. So we're almost finished with all of the class features in order to make our frequency table. So class midpoint. So this is defined as the arithmetic mean or the average of two class limits or class boundaries. So what does that mean mathematically, numerically? And when you do when you're doing your SBAs, you can apply some of these statistical rules or evidence or equations, etc., to get to those values. So class midpoint, you can either use the lower class limit and add it to the upper class limit, but you must divide it by 2. You can't leave it by itself. You can't just sum something and leave it by itself right now for class midpoint. Or you could use the lower class boundary, add it to the upper class boundary. So that is why it's so crucial for you to understand how you get the lower limits and how you get the class boundaries. All right? Well, class limits and the class boundaries, my bad. So these are the two equations that we can use, either or. We don't have to use both of them. All right? So calculating the class midpoints using the class limits. So we have our class interval. We have our class interval of 1 to 10. All right, and we have our midpoint. So again, we're using the class limits. So we have 1, which is our lower class limit, added to the upper class limit, which is 10. Are we all appreciating that right now? Are we all appreciating that? So what do we get? 11 halves. So we get that 5.5. So this is where you use a calculator and make sure you use it properly. For the other one, other class interval, you have 11 to 20. So what is my upper limit? Can anybody tell me what is my upper limit? What is my upper limit? What is my upper limit for the class
15.5.
interval 11 to 20?
20.
20. Now, Jonathan Walker, I noticed you put something in the chat, but you have 1 plus 10 all over 2. Now, you have to use brackets on your calculator if you're going to write something of that nature. So using your brackets is important. So you'll have open bracket 1 plus 10, close the bracket. Then you have the division by 2. Because what you technically wrote on the screen is that 1 plus 10 all over 2. So that means that you'll divide the 2 by the 10 first, which would give you 5. And then you add 1 to it, which gives you 6. And yes, I might be saying that early right now, but that would give you a different answer from what you should be getting. All right? That might give you an answer of 6. And you write 6, and it should be 5.5. All right? So make sure you're using the brackets on your calculator properly in order to eliminate errors. So this is using your class your class limit. Now, what about using the class boundaries? So we would have calculated our class boundaries, our lower class boundary and our upper class boundary. So we do the same, add them up, and then we divide them by 2. And as you can see, that both class midpoints, whether using class limits or class boundaries, gives you the same values. And these are for the first 2, of course. We would have worked out the others, but we just wanted to do the first 2. So we would have continued and done the rest. Is everybody okay with that? Is that fine? All right. Now we have a class, a CSEC question. We have a class basketball at sports day. So the distance turned by each student was measured to the nearest meter. So the results are as shown below. 22, 50, 35, 52, 47, 30, 48, 34, 45, 23, 43, 40, 55, 29, 46, 56, 43, 59, 36, 63, 54, 32, 49, 60. And remember, all of these distances were rounded to the nearest meter. All right? So pay close attention to the statement or the instruction, statement that was given in the questions that you have or will be doing in the near future. So we're going to create a frequency table. Well, technically, we're not going to use a tallies. So this is how the question was phrased, or this is how the question was on the paper. Now, what would be our class width? How do we find our class width?
I will subtract, sir.
Subtract what? So remember that our class width tells you the size of how many values are of the class interval. So what are we going to subtract? How are we going to find the class width?
The highest class limit and the lowest class limit.
The lower and you will subtract the lower class limit.
Lower limit 2. Lower limit 2 minus lower limit 1. So what is the lower limit 2? What is lower limit 2?
30, sir.
And what is lower limit 1?
20.
So we have what? 30 minus 20.
Yes, sir.
What is that?
10.
So I notice some persons are using 29 minus 20. That indicates that you have disregarded everything that was said earlier. All right? So you have to make sure that you're following. So the class width is equal to the lower limit 2 minus the lower limit 1. All right? So we identify the lower limit 2, and lower limit 1, and we subtracted those two values. So it's not 29 minus 20. That would have given you 9. 9 is not our class width. It is 10.
10.
Yeah, go ahead. Oh, go ahead.
Yes, sir. That's there. Yes, sir. That's there.
Yeah.
All right, never mind.
All right, cool. When the thoughts
Never
come
mind,
back
sir.
to you, you can share them, man. All right, cool. So our class width is 10. So they want you to copy and complete the table. And of course, you can do all of this. You can copy and complete the table, of course, as quickly as possible. They're asking you to complete the table. So what would be our next distance? And you notice they don't have class interval. They have a heading. So what would be our next class interval after 30 to 39?
40 to 49.
40 to 49. Yeah. What would come after that class interval or that distance?
50 to 59.
Okay. And last, after the distance 50 to 59, we have 60 to 69. All right. What would be our frequency for 40 to 49? I want you to give me that value quickly.
Sir, 8.
What would be your frequency? 8.
8.
All right. Do I hear 2 persons saying 8 or 1 person saying 8? Can somebody second that?
Or 1 person.
Right.
Yes, sir.
What about 50 to 59? All right, cool. 3 persons, 4, 5 persons, that's good enough for me. 50 to 59.
3, sir.
50 to 59.
6.
6
No,
or 4,
6,
which
sir,
one?
sir.
6, sir.
6. 4 plus 2 gives you the 6. And I'm putting up
6,
my
sir, 6,
fingers,
sir.
but you can't see me. All right, 60 to 69. What is the frequency? 60 to 69.
2.
Is it 2 or 3? Prince is in the chat saying 3.
2, sir.
Prince,
2, sir.
Prince, check your back.
2.
All right, 2. Now, what is the total or the number of persons who did this or who played it or took part in this sports day thing? How do you know? How much do you get?
Sir, 24.
Add up all the frequency numbers.
All right. And you can check by the data as well to make sure that you actually have the 24. So we have 3, 6, 8. We have in one row we have 8, the values in the data set, and we have 3 rows. So we multiply 8 by 3 to give us 24. All right. Well, yeah, 3 rows and technically 8 columns, but all right. What would be it says state. Notice it never asks you to calculate. It said to state. So once you do your calculation, if you're doing a calculation, then you just state the value. So state the lower boundary for the class interval. And remember that the class boundaries are halfway marks between the 2 consecutive intervals. So what would be the lower boundary for the class interval of 20 to 29?
19.5.
You might see lower boundaries or you might see lower class boundaries.
19.5.
19.
How did you get that 19.5?
By
Tell us all.
Drop 20 from 0.5.
Again, 20 from 0.5 is something completely different. It's 0.5.
0.5
The smaller number,
the
the smaller digit from the higher digit. All right? So it's 0.5 from the that value. So that gives you 19.5. What if I ask you the upper boundary? What would the upper boundary be?
29.5.
All right, at you. Got you. All right. So part D, determine the number of students who threw the ball at a distance recorded as 50 meters or more. What would that look like?
8.
Determine the number of students.
8.
All right, how did you get the 8?
Sir, we add.
Add what?
We add
the frequencies
the distance 50 to 59, there were 6 students,
yeah.
and 60 to 69, there were 2 students. You added 6 and a 2.
All right. So let me just add a bit. So when it says 50 meters or more, what inequality symbol do we generally use for that? Can anybody tell me? What inequality symbol do we normally use
Greater than 50.
when it says 50 or more? Huh?
Greater than 50.
Is it really, should we use a greater than sign?
Greater than or equal to 50.
All right. And I want you all to make sure you understand how to write that symbol. All right. I know you can't write it on the computer, but you could write the greater than and then write the equal sign as what Tyrese did. So DC, you need to check back your inequality symbols. All right. So the throws is greater than or equal to 50. So whenever you see that, it indicates, or whenever you see the words or more, that means greater than or equal to. All right. So yes, you are correct. 6 added to 2, that's 8. Measure of central density. Okay. So I will give you 2 minutes to get some water, stretch your legs, and then we continue with our 3rd out of 4 objectives for today. All right?
Yes, sir.
So at 10:43 on my clock, well, on my computer time, we should be ready. Or we can always stick around. I just started standing. Funny. All right, we're sitting now. Are we standing? I would say. Hello, everything. I think. All right, so on to measures of central tendencies, right? Okay, cool, sure. So we're gonna use our measures of central tendencies in order to complete the questions that we have in store. So let's go. Is everybody back, by the way? All right, you never left.
Yes, miss.
Hope you never,
Yes, sir.
never left. So the measures of central tendency are
Breaking up, sir. Breaking up.
How about measures of central tendency? Is everybody hear me?
No, sir, you're lagging.
Breaking up, sir.
Oh no.
Sir, break up server, sir.
You're just cutting and then you're cutting out.
Yeah, cut out and a cutting back.
Oh no.
Sir.
What about now? You hear me now?
Yes, sir.
Yes, sir. You're
No.
back. You were away for a while.
5 seconds.
Never went away. That was just the internet lagging, everyone. All right, measures of central tendency. So as I was saying, there are averages, right? So that's another way of putting them, as average. So as a number representing the central or typical value of a data set or set of data. So the common averages are the most common averages that you'll hear about. Can anybody tell me, or do you know of any the common averages that we generally use? You have been doing them from prep school. I'll give you one. Mean.
Median,
I know
mode.
everyone should fall in line now. Okay. More than median.
Median.
All right, nice.
Range.
All right. So range is technically. All right, let's go. So I like my Clarks. I really do like my Clarks. But anyways, it's not Carl, but Carl's Clark crisis. Now, Carl has a store. All right, he want to make up a small business where he wants to buy and sell Clarks in his community. And yes, you might want to do that eventually, or do something that would give you more income. So he remembered his averages.
Yeah, cut out again, sir.
Lagging.
Sir, we can't hear you.
Lagging. That's a new term now.
Hearing you now, sir.
Okay, fantastic. I'm not lagging anymore. All right, cool. Thanks, everyone, for reminding us. All right. So he's trying to remember what statistical averages his teacher would have mentioned that he could use, right? So he's trying to use that in order to garner what should he do? What particular things should he sell, etc. Or what type of clock should he sell? Yeah, that should be Clark's. So the clock sizes. Sorry. So let's remind Carl about the statistical averages and help him in deciding which one he should use to start his business. So the first one, mean. So mean is the average, yes, that we are all familiar with. All right? And how do we generally find mean? Can anyone tell me how do we generally find mean?
So you add all the numbers and you divide by how many numbers are there.
Lag again, sir. Yeah, lag
Sir,
again.
lag up, sir. Lag up. Sir, lag, sir.
Not hearing anything now, Miss Alimi.
I don't know.
Daily. Yeah, chip in or chip out.
Statistics prefer to have the mean as
Sir, you might have to rejoin again.
Oh, Miss Alimi, we're not hearing you. Your mic is closed. Okay, you're open now. Go ahead and
Is
speak.
everybody hearing me now?
Yes, we are hearing you. You're back.
Okay.
Strong.
Statisticians prefer to think of mean as a central balance point. So, in other words, how do we find mean? As you
Excuse me,
have
sir.
indicated earlier.
Sir, we missed everything from the mean is the average. We didn't get what it said about the number or this. You just came back. So we missed everything you said on the second bullet point. So if you could go back over that, that would be great, please, sir.
The mic is closed, Mr. Limi.
A number You hear me now?
Yes,
Yes,
sir.
we're hearing you.
Yes, sir. Yes, sir.
A number that represents the typical value if the data values were evenly distributed. So it's not just about calculating something using an equation, but it is literally trying to get everybody a fair share. You're trying to evenly distribute the thing. All right? So statisticians prefer to think of mean as a central balance point. So yes, you would have given me another way of calculating the mean using different words, but the words that I'll be using is that the mean is the sum of the data divided by the number of the data points. And similar to what the young man said earlier, that is what we could also use. All right? Is everybody clear with that one?
Yes, sir.
Yes,
Is that
sir.
fine?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now, the real truth about this is that we have a question that we should explore some truth to that, about being evenly distributed. So the diagram below uses bars, which are stacks of cubes to represent the cost for the 6 toys. Now, you're seeing at the bottom, I would hope, of this diagram that you're connecting the cubes. The connecting cubes are stacked. So each cube represents $1. So that cube on the far right, that one that looks kind of yellow, might look orange on some of us screens. Well, it is yellow, I think. Men are colorblind, sorry. So that is $1. So each cube that you're seeing represents $1. Is everybody okay with that?
Yes, sir. Yes,
Is
sir.
that okay?
Yes, sir.
Okay. Now, we want you to use the stacks of bars that you're seeing to determine what price would be, what would the price would be if you're if you're buying all the toys at the same price, or the cost of the toys for the same price. So how would you use this figure now and what was said at the bottom of the figure or the diagram in order to answer that question? What do you think we can do?
So we're going to add up all of the blocks and divide it by how many are there.
All right, you're going straight to the formula. So think about this visually. I haven't necessarily, well, I did so to some extent, but think about the figure or the images that you're seeing right now. How could I remember the key point that I mentioned earlier is to make sure that it's fair, it's evenly distributed. So how would you use these cubes in order to make sure that all the toys have the same price? The toys don't have the labels on them, but yeah.
Add up everything and divide it by how much group is there.
All right. So for the blue, all right, go ahead. Sorry.
Yes, add up all the cubes and divide it by how many stacks of cubes are there.
All right. So can we say that right now, all of these cubes are evenly distributed? Can we say that?
No, sir. No, sir.
No.
You have to
So how
stack
would
all
we
of them
make?
by 6.
How would we
Stack
make?
all of them by 6, sir.
Okay, stack all of them by 6. But how do you know that we should stack all of them by 6?
Because when you count, you're gonna get a total of 36
34.
cubes.
No, I don't know if when you're kids, or when I was a kid, you know, you usually play with certain things and then you say, oh, I want this. You might probably don't want it to be the same size, but you want to stack them up and say, oh, I can use this. I'll level them off. So technically, that's what we can do. So you want to rearrange the cubes to level the prices. So I make the prices same. So yes, I know that everyone was saying add up all of the cubes, then divide it by the number. But you could also level off the things, level off the cubes for the toys. So what does this look like? That is what it looks like. So coming from the image on the left to going on to the image of the right, you should be able to tell now that the image on the right, all of the toys, each of the stacks of cubes represents a toy. So all of the toys are on the same they're on the same level. So I technically don't have to actually have a number to say that this is what I do to find the mean. I want to make sure that everybody is fairly given the same amount of cubes. All right? So doing that will assist with that part. So these were the toys, the values for the toys, which I would have hidden in order to make sure you got something from it instead of just saying, oh, this is 12, this is 8, and all of that, right? So when you see the numbers, you might go straight forward to that thing. So the next one is mode. So the mode is the most frequent number of mode is the most frequent number or item. That is the number or item that occurs the most number of times. So generally speaking, most persons kind of get mode more than any other statistical average. So for this chart that I have, you should be able to calculate or find the mean. Sorry, the mode. The mode is the what? Which color represents the mode?
Green.
And how do you know? How do you know it's green? Why not the other colors?
Because
What do you use to signify?
The
most frequent.
It is the most
It's the tallest. It's the tallest bar.
Yes, sir.
All right. So that's what we could use. All right. So if no number in the list of data set that you have is repeated, then there is no mode for the list. All right?
Yes, sir.
So if no number in the list is repeated, then there is no mode at all. So you just have 1, 2, 3, 4, 5. There is no mode in that. All right? Because there is no number item that occurs the most number of times. Each of the items occur at the same time. All right? So second point, there can be more than one modal value. And you see modal. What does modal come from? Which one of the statistics does modal come from?
Mode.
So if you should see modal, it means that you're really finding a mode. So do not be deterred or confused or say, oh, I've never yet seen this term before. I don't know which statistical averages it would represent. But I am indicating now that using our English language, we should be able to ascertain this value. So the link, the YouTube link, the YouTube channel is where you'll find the recording of this session. All right?
What's the
So
name
don't
of the
worry
YouTube
about
channel?
that. One of my colleagues will post it in a short while. Just give them a second and they will address you in kind. All right? So median,
Yes.
what is the median to us? Let me hear what
The
you
middle
think.
number.
What do you think the median is?
Middle number.
When they arrange all the numbers in order, it's the
When you
middle number.
Into
So
highest
So when
lowest.
you rearrange the numbers and
Numbers in
number that
order and
appears
find
in the
this
center.
When you
middle
rearrange
number.
numbers and
All
all
right.
that is in the middle.
All right, nice. So I like the individual who said that they are arranged in an order. So it's not the median value alone signifies a median. It means that data must be sorted. So don't look for the bigger number and say, okay, the middle value, sorry, or the middle item, well, technically item, and say that this is your median. It has to be in an order, right? And as the person said, once you have two values that are in the median position, then they will divide it by 2, all right? That's lovely. Thanks for pointing that out as well. So you want to make sure that your values are in an order. So when you have a group data, the values will be in order, right? And likewise, the other one. So could you tell me the median for this? The data set that I have right now, 428115. What is the median?
8.
4.
Oh, 4.
4, sir.
And that's how we get tricked, you know.
4, sir.
I literally said the same thing and we're doing the same thing earlier. So we actually need to arrange it. So yes, it is 4, but we need to arrange it in an order. So 1, 2, 4, 8, 15. And even if you arrange it from the largest to the smallest, your middle value, your middle position will be 4.
It's gonna be the
right? So yes, it would be the same. So don't take it for granted that it will always be in a particular order, all right? Sometimes it will be jumbled up, and it is you, the student, or the person who's going to do the exam, must understand that it's not the middle value, all right? So if there are 2 middle numbers, as an individual said earlier, we take the mean of these 2 numbers. In other words, we add those 2 values together and divide it by 2 to get the median position or value. So back to this, the Clark's thing. So which measure of central tendency would best help Carl with his Clark's business? Would it be mean, mode, or median?
The mode, sir.
Why do you think the mode?
Most common, sir. So you have to get the most common one out of all of them.
Most frequent, not common.
Yes, sir.
Most frequent. So that's what we use. All right. So the most frequent is what would dictate which class or type of class he will buy. So if something technically looks ugly, that class looks ugly and nobody will buy it, then you don't want to go for that. You want to look for something that everybody likes. And what do you all like? Can anybody tell me? What type of class do you all like? Go ahead, just
Bunky and Wallaby.
Which one?
Wallaby.
Wallaby?
Bunker and Wallaby.
All right, Wallaby. Desert. All right. You see
Just
them
regular
clocks,
black folks.
them clocks they go and sell. They can sell the Wallaby and maybe the Desert and the bank robber, right? So those are the types of clocks that you probably would purchase more. And you probably might go into and say, oh, the size. Which size most persons wear? You might take a look at survey and say, all right, and then you buy those sizes. And when you see them run out of those sizes, that means a lot of persons are buying those sizes. All right. So we use a mode to assist us with that one. So you look at everyday scenario and you apply it to your business, your future business. You don't want to put a gas station in a particular place where you have 6 or so gas stations 1 kilometers away from each other. No, that's bad for business. You want to put it somewhere where everybody might want to go or whatnot, a central place. All right. So you have to check out all of those things. So that's how math helps you, whether it be financially or location wise, etc. So we said the mode. Now the raw data below is actually a factual data when we had the COVID. Well, let me not say. Yeah, when we had the COVID-19. So this was taken in a week of November 8 to 14 of 2020. So this is a raw data set, 0310222. I said 223 4 times, but it should be 3 times. So what is the mean number of recoveries for the week? Can anyone give me that value or calculate that value? What is the mean number of recoveries for the week? Let me hear what you all say in the chat. What is the mean number of recoveries for the week? What is the mean number of recoveries for the week? All right. Somebody says 2.
Sir, 2.
All right. Let's. All right. Let's see the calculation. 1.43. That's what you got?
Yes, sir.
All right. Let's see. So let's do the thing together. So the sum of the data divided by the number 03022, and that is our values, and then we sum them. And then our 7 is the number of data points that we had. So do not think that 0 is not significant. 0 is significant in this calculation when we're doing mean, mode, or median. All right? Don't disregard it. So we have 10/7. So as 1.4 or 1.
Sorry, still I break up.
How about now?
Better, sir, better.
All right, thanks. So we have 1.3. But what did the question tell us? It says this is a daily number of recoveries, right? So are we talking about, what are we talking about? Are we talking about humans, objects? What are we talking about?
We're talking about humans.
What do you think we're talking about? Humans. So now my question, do we have 1.43 of a human being?
No, sir, sir, the one.
So do we say 1 or do we say 2?
1.
You're gonna round it, so you have to get
One, sir.
One.
All
1
right,
because
let's see.
5.
All right. So remember, it's the context of the question that will generally tell you what to do. So in this question, you're actually rounding up, and you might find that a bit awkward, but again, the context is important. So we actually should be saying that the mean number of recoveries for that particular week is 2. So 2 persons would have at least recovered, right? At the minimum, 2 persons would have recovered. One statement. We got 1.4. When we say 1,
Break up, sir, yeah, break up.
underlines,
Break up, sir.
when underlines actual data.
Sir, you're gone, sir.
Hello?
Yes, you're back, sir.
You better know, sir.
Okay, thanks. So I was saying that if you say 1, you're underlining the data, right? Because it's not actually exactly 1. It is more than 1, but we can't say 1. So more than 1, in this circumstance, we have to say 2 persons would have recovered. All right? Is everybody clear with that? So the context is very important. All right?
So,
Is that
sir,
cool for everybody?
so sir, you're saying although normally this would require us to round down, so to the nearest whole number it would be 1, but in this case, because we need the numbers and we don't want to what am I going to say now? We don't want to underestimate. It's better to overestimate in this case. So correctly
Yes.
rounding off, we would round down in this case because the 4 is less than the 5 that we usually use. But in this case, it is clear that underestimation would not be good for this statistical situation. So it is ideal, it is better to round up in this context. So the context is what is causing us to round up. Is that what you're saying, sir?
Yes, yes, yes. You hearing me? Yes.
Yes, sir.
Oh, you hearing me now? No?
Yes, sir, yes, sir.
Yes, yes, Mrs. Darby. So that's why we're running up, as the context of this question is quite important. All right, so normally we would have rounded down to 1, but because of the context of the question, we're dealing with human beings. This is why we round up that value to the nearest, well, not to the nearest whole number, but in that case, we add to get 2. All right? All right, let's continue. Can I continue? Is everybody clear with that?
Yes, sir, you can continue.
All right, thanks much.
Just a second, sir. Just want to encourage students to focus on the lesson. I'm seeing some distracting chatter in the chat, and although I'm speaking to students, just focus on the lesson, please. Thank you, sir.
All right, thanks for that. So the modal number. And what does modal represent? Which statistical average does modal represent?
Mode.
Mean, mode, or median? Okay, mode. So what is the modal number of recoveries for that week?
Sir, 2.
What is it?
2, sir.
All right. that's the most frequent number of recoveries, which is all right. What about the median number of recoveries?
2 again.
2, sir.
You must place it in. Remember to place or sort them in an ascending or descending order.
Yeah, that's
So I did ascending order, and that's how I got the 2, right? So the median number of recoveries. Thank you, Jonathan Walker, for writing that down, and we get 2. All right. Is everybody clear with that? Is everybody okay with that?
Yes, sir.
Yes,
All right,
sir.
nice. So as a student council president, Nicola approached you about challenges faced by her grade 11 history class, students in history class. She mentioned that the entire class was not doing well and the class average was below 60% required to pass. So again, the class average was 60%, and she's saying that it is below that value, all right? Below the 60%. So here is a frequency table of the results on the end of the term examination. On the end of term examination, does she have a legitimate concern? So let's look at the table. So the table represents the grade 11 students' test scores. And you should be able to notice that it's from the lowest to the highest. And we have the frequency on the right column or in the second column. So the question is now, besides legitimate that you have, what is the more appropriate statistics to use and why? So let's do the mode. What is the mode? What is the modal score for this particular grade 11 students? Their test scores. What is the mode? What would be the mode?
14, sir.
What would be the modal value? How much?
14. Well,
What is the modal score? How much? Can't hear you.
70.
70%. So 70 represents our mode. What about our median? How would we find our median for this data set? How would we find our median?
So I would say
How do we find the median?
times all the frequencies to the history percentage, and then add all of those and then divide it by the total.
Median.
Oh, median.
Let me just write it. Yeah, median. So how do we find the
From 0
median?
to 80. We're gonna arrange the data and look
All
for
right,
the
so
middle
start me
number.
off. How would I arrange the data? What should I write first?
So
What should I
0.
write first? Repeat?
0.
Should I write just 1 0?
Yes, sir.
Yes, sir. 3 zeros. 3
Really
zeros.
now, what is the frequency for how many persons got 0?
Oh, sir, then.
Yes, sir. 3 zeros are good.
All right, so we have 3 zeros. And how many 40% should we write? Well, 40 in this scenario, because this is percentage 2. And we continue like that. So we don't just write 1 0 and expect us to get the answer. We have to write the entire data set. It's a long, I will show a shorter way in a bit. So this is the long way of doing it, right?
Yes,
so
sir.
How would we separate now to find the median value? What will you do to separate to find the median value?
Sir, guess we remove some
Can
of
anybody tell me?
And the total number of frequencies.
You want to make sure they're evenly distributed. So the top half and the bottom half. So start with 0 and count it, and then you want to do the same thing for the bottom part of it. So when you do all of that, our median is 2 numbers, which is 70. So again, using the bottom half and count up the number of values that you're seeing, and then evenly distribute them. So let me see. I have all of this. How much numbers is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 9 numbers, right? At the bottom half. So I'm going to do the same thing for the top half. So I'm going to find 9 numbers. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 right here. Yeah, that's 9. All right, cool. So that's 9. So I still haven't found my median, right? I mean my median position. So I do the same thing. I count out. So this is, how much is this? 4. Let me count 5. So this is 5 numbers at the bottom half. And I do the same thing for the top half. So I have my 60 down here. 60, 60, 60, 60, 70. Those are 5 numbers from the top half. So this is why I now end up with 2 numbers that are in the median position. So what do I do with those 2 numbers?
You add them together.
Them. Yeah, but yeah, so 70 plus 70 is 140. Then we divide it by 2, right? Which gives us what? 140.
70.
Yes, 70. So what is the median? 70. So which other one is left now? Which other statistical measure is left? We did the mode, the median. Which other one is left?
Mean.
Mean. All right.
Mean, sir.
So this was the shorter way. Instead of listing all of the values, all of the scores, you can determine the median score by using the total frequency. So you have 3 added to 2, added to 2, added to 6, added to 14, added to 3. That gives you 30. You divide it by 2, which gives you the 15th position. Now, what does the 15th position indicate? This is what the 15th position indicates. So I have this 3 and the 2. What does that give us? That gives you what? 5. So that is the 5th position. Then you continue. You add the 5 to the 2. What do you get? 7. Is that my 15th position? No. I continue. I get to the 6. So I'm adding the frequencies until I get 15. So 3 plus 2 plus 2 plus 6. That's how much? 5. That's 13. So where would my median value lie now? My median value would lie right there in the frequency of the 14. But remember that the 14 is not your answer. What is your answer? The 14 represents the 70%. So the 70% is your median value. So this is a short way of doing it instead of listing all the values. So most persons will do the short way because sometimes you won't be able to list out all of the numbers. You're wasting time when you do that. All right. So this is a short way of doing it, and it's very effective when you have a large data set. All right. So this is how we do it. So we use the frequency until we get the 15th position for this particular question, and then we get to that answer. Is there any issues with that one? Are we all on the same page? Yes? No? Maybe? All right, cool. Nice. Let's move. So the mean, how do we calculate the mean? What is the sum of the data? How do we find the mean for this value? What is the sum of the mean? What do we use? Do we use just 0, 40, 50, 60, and 70, and 80? And that's our value? What do we use?
The frequency.
Somebody would have said it at the beginning of the session, and I hope they're here to see it now.
Oh, sir.
What do you do?
You're gonna times all of them, the frequency to the percentage.
All right, so we have 3 times 0, and then what? 40 times 2?
Yes, sir.
2, 60 times 60, sorry, 60 times 70 times 40, and 80 times 3. All those are added together. And what do they give you? 1,760 and divided by 30. So that gives you 58.67 to 2 decimal places. And we're going to run this up to the, yeah, go ahead. Okay. So we're going to run this up to the nearest percentage. When we round up 58.67 to the nearest percentage, what do we get? When we round up 58.67% to the nearest percent, or some persons might say nearest whole number. What do we get? What is the value? Okay, 59. 50. All right, great.
Sir.
So we still haven't answered. Yes, go ahead. Oh, you said 59. All right. So we still haven't answered the question. We found the mean, the mode, and the median. Now, let's conclude by saying, does Nicole have a legitimate concern? So we found the modal score, which is 70. We have the median, which is 70, and the pass mark, which is 60. And we have the mean score that we evaluated a bit further to get that value. So do we now think which one of these would represent, which one of these is most appropriate to say that, oh, she has a legitimate concern or no legitimate concern? What can we use?
The mean score.
Mean, sir, the mean.
The mean score.
All right, you want to use the mean? All right, let's query that. So what was the pass mark?
60, sir.
60,
what was the pass mark? 60. How many persons got, what was the modal score?
70.
What was the modal score? And how much persons got 70?
40.
All right, the next question. How much persons passed this test in this class?
17, sir.
How much persons passed the test?
70. No.
How much?
23, sir.
23.
By adding up the 6, the 14, and the 3. And how many persons are in this class? 30. So you're telling me that 23 out of 30 persons passed this test, and you're gonna tell me that everybody feels the average is below 60%? Does that make sense? Does she actually have a legitimate?
You're lagging. Could you say that again, please? You lagged a while ago. Could you say that again, please?
We have 23 persons out of the 30 passed. Is everybody hearing that?
Yes, sir.
Very well, yeah.
Yeah, so if 23 persons pass out of 30, and the pass mark was 60%, and she's saying that because the mean that we found is 59, and that's less than the pass mark, that means the entire class not do well. So is that true? Is that factual? Because we see the mean, that's what we think is the final answer, and that's what we rock with. We need to analyze or interpret the data more. So more persons actually pass. So it's not factual. So this mean is going to give you a misinterpretation or a misrepresentation of the data, because you have two outliers. 3 persons who got 0, 2 persons who got 40, and 2 other persons got 50. So the statistics that we're going to use, the appropriate one, would be the mode, right? Because the mean is not telling you the actual thing of what's happening. So this is how you analyze and interpret your data. And not just leave everything up to chance and say, oh, the class average is this, so everybody in this class is at this standard, all right? But have you analyzed your data more than just looking at the surface? So that is what you need to do, all right? So everyone can appreciate why it is the mode and not the mean?
Yes, sir.
And why?
Yes, sir.
Okay.
Yes, sir.
So do not let the surface trick you. But if you want to go too deep, and not too deep though, I want to find out what is actually happening down there. And in physics, it's the same laws of refraction. Well, let me not get into that. Next activity. Is everybody hearing me?
Yes, sir.
All right, so David grew some carrots to make some extra money. He dug up 50 carrots and measured their mass to the nearest gram. So it's quite important for you to all to understand what the statement is saying, and don't take everything for granted. So this is our table, our frequency table. These are the information we have modal class? What is the nearest gram? And what is the median mass? So we'll be answering those questions. So from the get-go, I think everyone should be appreciated. Technically, no, just for today. But we'll have a next session in February thereabout. So it's more or less when you guys have holidays. All right. So what is a modal class? What do you think is a modal class? Based on the data that you have right in front of you. What is a modal class? How do we find a modal class? What is it? Can't hear you. Can't hear you.
20.
20? What is the modal class? Is the modal class 20? Is the modal class a frequency? What am I going to do with that 20? Again, yes, you look at it, the number of times, the one that is most frequent is 20, yes. But that's not our final answer. We look at the
doesn't
mass.
necessarily mean it's a modal.
60 to 64.
Exactly. So we just use that to identify which frequency, and we lead it back to our mass, our modal, our class intervals. So it's 60 to 64. What about our mean mass? How will we calculate the mean mass? What would we need to find?
Well,
And I think the first, repeat. Can we say 7 multiplied by 50 to 54? Can we say that, everyone?
No, sir.
Okay.
So what are we going to use? Because we don't know the actual values, you know. So what are we going to use? Repeat.
Use the middle number, which would be 52.
The middle number, and a middle number we say, what do we say? What is the perfect term for this?
Sir.
Yes, it does start with M, but we discussed this earlier. So what is it that we actually, the midpoint? Yes, Jonathan Walker. What good. All right, midpoint. So how do we find the midpoint for the mass when it is measured 50 to 54? Let's see if anybody remembers. How do we find the midpoint for the mass of 50 to 54? What do we do? And then what is our final value? So just giving you 10 seconds before I reveal. Okay, 50 plus the 54. So the lower class limit added to the upper class limit. So we get 52, right? Continue. 50 to 59, what is the midpoint? What is the midpoint? 50 to 59, what is our midpoint for that? Yes, and remember to use the brackets. I love to emphasize that as well. Thanks for that one. So 55 to 59, what is our midpoint? Calculate it and give me that value. 57, nice. 60 to 64, what is our midpoint? Okay, 62. 65 to 69, what is our midpoint?
67.
Okay, 70 to 74? 70 to 74?
72.
All right, do you see anything worth noting for the midpoints? The values
Pattern.
that you see a pattern. What a pattern?
Right, he's going up by 5, sir.
All right, so that's the connection that you're making. It's going up by 5. So if you should miscount, or you see something, and you say, oh, this don't make sense. No, I'm add up these, this was give me that value. There's a pattern or adding by 5, or the difference of 5. All right, so what do we do with that midpoint? We have our frequency, and we have our X. So F means frequency, X means midpoint. So what do I do with F and X? Do I add them? Do I subtract them? Do I divide them or multiply them? Which one of the operations will we be doing with the frequency and the midpoint? And someone again would have alluded to this earlier today. So let's see if we all remember. So what do we do with the F and X? What operation do we do? Any suggestions? So we actually multiply. Yes, yes, good Walker. You're using the brackets now. Emphasis on that. So what is 7 times 52? Can anybody give me the answer quickly?
364.
All right, remember, we did say that you're supposed to have a calculator. So quickly do the next one. 14 times 57, and then I'll just reveal the others.
790.
790.
All right, and I'm revealing the others. So what will this give us? This will give us our summation of f multiplied by x. And why do we need that? Because that is our sum of the data. And why did we do that? Because we can't say 7 multiplied by 50 to 54, right? So this is why we found the midpoint, because this is a group data. So whenever we have group data, we have to find the midpoints. When this is a ungroup data, you can just multiply the frequency by the age or whatever it is in the first column. All right? So that is a major difference. So for the person who said f of x at the beginning, I hope you now appreciate when we actually use it, when we have group data. All right? And then we do the division, we get 60.4. So 60.4 is the class, sorry, not the class midpoint, but it's the median mass. And remember that we should round up our answers to the nearest grams. So that's 60 grams. All right, what about our median position? Let's use a simpler method because we don't want to write out all of these values. It might take us 10 or 15 minutes to write out all of those values. But yet again, can I actually write out these values? Yes or no? Do I know the values? Can I actually write them out?
No, sir.
No, because again, it was not given to us. They just gave us this table to use. So what is our total frequency? Can anybody tell me what is the total frequency?
40.
40 or 50? Which one?
50.
Which one?
50.
Okay, 50. So 50 divided by 2 is what? 25. So we're looking for the 25 position. I want you now to give me the median mass that is in the 25 position, 25th position, my bad. Go ahead. Waiting on that one. Let's see if you remember what I did earlier or how I manipulated the table to get my value. What is the 25th position or the 25th term? In other words, the 25th position will give you the median mass. What is that? Let's see, giving you all 20 seconds.
The 25th position is in the 60 to 64.
All right, let's go and add just for verification. So we have the 6, the 7, and the 14. That gives you 21, right? Is the 21 position what we want?
No,
based
sir.
on our calculation? No. So where would the 25th lie? It would lie somewhere in this region of 60 to 64.
Yes,
right? It's in that part. It's not out of it, it's inside of it. But you don't know which number, but you know the class interval of 60 to 64. All right? So that is how we do this thing, and we do it well and to the best of our ability. So the median mass will be in the class interval of 60 to 64. All right. So a class of 30 students. So a class of 30 students counting the number of bags in their books on a certain day. So using the table, we want to calculate the total number of books, the mean number of books in each bag. So this is our table. And we'll have it shortly on the side. Okay, that came up quicker. All right, how would I find the total number of books? How would I find the total number of books? What would I do?
Add the frequency.
The total number of books add the frequency?
Add the frequency.
So I should add up 2, 3, 5, 6, 7, 4, and 3 and get my answer for the total number of books?
No, sir. Frequency, you not get the total.
No, sir. Add up the number.
Multiply the frequency by the book.
All right, Tyrese, sorry to cut you short. Tyrese said multiply the number of books by the frequency. So does that make sense? Think about it.
Yes, sir. Yes,
Let's
sir.
connect now.
Yes, sir.
Because how many persons have one book? We have 2. So how many books do they have in total? They have 2 times 1, which is 2, right? And we continue. Frequency, we have number of books is 2. How many persons have 2 books? 3 persons. So 3 times 2 is 6. So let's see if we can add up those values and give me that answer. What is the total number of books? So again, we're multiplying the number of books, as Tyrese rightfully said, by the frequency. So X times F. And you're seeing, you should be seeing it on the right side of the screen as well. So that's how I got the 2, the 6, the 15, the 24, 35, 24, 21. So add up all of those and tell me what you get.
122, 27, 127.
Okay, 127, right?
27.
So that's the total number of books. How do we calculate the mean number of books? Lawrence, you need to check back your answer. Remember, you're adding 2, 6, 15, 14, 35, 24, and 21. Wait, are you calculating the mean? Sorry. So we're calculating the mean. What will we use to calculate the mean? We have the total number of books, which is the sum of our data. Do we have anything else? Do we have anything else? How do we find the mean? The sum of the data and the sum of the number of points that we have.
Right, sir.
Divide.
All right, so what do we divide? Tell me the values that you're going to divide. So total number of books by the
Divided
number
by
of books.
some.
Is it the number of books or is it the total frequency?
The total frequency, sir.
Total frequency. So you want to make sure that you're using the correct terminologies. So they might connect to you and you might say, oh yeah, this it mean, but you really write a different number than compared to what you want to write in words. So it's 127 divided by 30. What does that give? Okay, it gives us 4.23.
4.23.
4.23.
All right. So can I have 4.23 books in my bag?
No, sir.
No, sir.
So
I
what
roll it. I roll it to
5.
So is it 5 or is it 4?
5.
4.
5, sir. 5.
5.
4, sir. 4.
All right. For the person who
5.
said 4, tell me why it's the 4, please.
Run it up.
So this one is dealing about objects.
Actually, sir, it will be 5
So
because
in this one, we actually round down, right?
Yes. 4.
So remember, and even in the question, in the table, you have either 1, 2, 3, 4, 5, 6, 7 books in the person's bag, right? So the person who got 18, that should never happen because you don't even have so many books that were given in the table for the number of books in an individual's bag. So you could never get that value. So onto the 4.23, we will approximate it, as you would have said, as 4 books, right? So we round down in this sense, right? So if it was something about a human, an animal, then we would round up to give us 5, right? To that context. But this context is about an object, which is a book, right? So this is why I said to you that the context of the questions are quite important in your final values or final answers. All right? So don't take it for granted. Okay? Because if they had 5 books, think about it. If they had 5 books, each person had 5 books, let's just say there are 30 persons. So when we multiply 30 by 5, how much do we get? What is 30 multiplied by 5? 30 multiplied by 5.
150, 150.
So did we get 150 for the total number of books? Is that closer?
No.
That the far off from our value, right? So when we say 3 times 4, 4 times 30, we get 120. And yes, that's still an understatement, but it is still close as possible to the 127, right? So again, we can use that. Again, stop thinking about the surface. Think about how we can a little bit more technical but you're diving deeper into it to see what you really have. All right? So that's how we get the 4 books. Is everybody clear with that one?
Yes, sir.
Yes, sir.
Yes, sir.
All right, cool. Nice. Keep it up. Now our final what you call it? Objective is standard deviation. Now, standard deviation for CSEC mathematics does not involve any calculations. As in, you're not calculating the standard deviation. You will do that in additional mathematics if you should choose to do that. Or in CAPE mathematics. Well, I really don't need in CAPE, but yeah. But for CSEC math, we're just comparing the values. So they will give you the standard deviation value, and it is for you to interpret what this is saying to you. All right? So do not be afraid when you actually Google it and you see standard deviation, you see the formula. Don't think about the formula for this level. But when you go to college, you'll have to think about the formula. But food for thought for everyone. So standard deviation is the measure of the spread, or what we call dispersion, of the data around the mean. So it is centered about the average, which we call the mean. All right? So what does this further tell us? It indicates whether a data set is consistent or varied. In other words, it can also signify in a classroom that you're in to say, are these students consistently performing at a high level, or is the data, or is the are the students in the classroom, they have varied results? Varied meaning they have up and down results. 1 minute you get 20, the next minute you get 100, and next minute you shot it, you get whatever. So it continues like that. There is no consistency. So we use standard deviation to show consistency and variation around the mean or the average. So a larger value means more spread, while a smaller value means the data is clustered nearer to the mean. So if your standard deviation is a lower number compared to another standard deviation, which is higher, then the lower number indicates that that result is closer to the mean, right? But the larger value is further away from the mean. So that is how we adapt, and that is how we really think about standard deviation. How close or how wide? Something similar to range, but this is not range, all right? We're using the mean, so it's around the mean. Is that clear?
Yes, sir.
All right.
Sir.
Yeah, go ahead. Oh. So a low standard deviation means the scores or the data points are close to the mean, which shows consistency. So the lower the standard deviation, the more consistent your class is performing, your literal class, in mathematics, in the 8 subjects or how many subjects that the class is doing, etc. So whenever it is lower, that's what we really use. So an example of this is when a student performs consistently, right? There's no fluctuation. So they have a low standard deviation. High standard deviation means that the scores are they spread out, indicating that you might be running at a good speed in 100 meter, 400 meter, whatever it is. You might have an injury, and then you perform below your expectations. So there's a variation in ability. So the analysts or the commentators might say that the person is consistent, right? So we can also use that. Is everybody hearing me?
Yes, sir.
Am I being heard?
Yes, sir.
All right, cool.
Yes,
so
sir.
I'm just showing you how this mathematics can be related to your sports, your academy, whatever it is. You can use mathematics to tell. And remember, numbers don't lie. That's a popular song, but I won't get into that. So example of this is when a student scores very high sometimes and very low other times. So we say inconsistent, all right? And in football, we say class is permanent, form is temporary. So that is something that you can also think about as well. So I'm just using certain things so it might click to you and the girls as well, volleyball, whatever it is, netball, you can use that to dictate or remember certain things in mathematics and in any other subject. So in a mathematics test that was taken by 2 classes. So you have class A and B. So we have the mean mark for class A and class B to be 65, but the standard deviation for class A is 8, and the standard deviation for class B is 4. So my question to you, to everyone on this platform, which class perform more consistently? And can you explain why? So,
Class B.
Class B? Okay, why?
It
Why
have a
is it
lower.
class
Deviation is low. It's
So
lower
what about the
than
mean?
class
What about the
A's
mean? I don't
deviation.
care about the mean. Do I care about the mean then?
And they have the same mean, so
Okay, so they have the same mean, so we can somewhat overlook that. So we speak about the standard deviation. So the lower the standard deviation, what does that say to your data? What
more
does that say about the
consistent.
class?
The
They are
more
more what?
consistent. Yeah.
Consistent. All right. So they are further away by 8. Class A. So it's not so consistent. So let's look at the answer now. So class B performed more consistently. So both classes, as we indicated, have the same mean of the mark, 65. However, the class B has a smaller standard deviation, which is 4, compared to the class A, which has a standard deviation of 8. So what this means, as we would have highlighted, and as that 2 or 3 persons would have indicated, voiced their opinions, to say that class B is closer to the mean. All right? So this is why we say that class B would have performed consistently. All right? Is that clear? Is that clear? Yes?
Yes, sir.
No?
Yes,
All
sir.
right.
Yes.
All right, good. All right. So we have this table. It's not completed, but the first question that we wanted to ask everyone, can you state the modal class interval? And by the way, you don't just go straight to the question. I'm just doing that to show you what we generally do wrong. We should read the instruction of the statement, which says that the score is obtained by 100 children in a you observe your table, then you make your inferences or your what you observe, and then you go to the question. So don't just jump to the question, people. That's how we generally assume and get it wrong. Okay? So once you have analyzed the table, then you go to the first question. Then you can answer. So I have done my analysis, my observations from the table, and I hope you would have made your own inferences. And then we go to the next slide. So state the modal class interval. And remember, with statistics, what average do we represent, or what average speaks to the modal? The modal. Is it mean, mode, or median?
Medium.
No, it's a medium, but it's mode. Mode. All right? Modal comes from mode. All right? All right. So what is the modal class interval?
20 to 29.
20 to what?
29.
All right. So again, the modal class refers to the class interval with the highest frequency. So the highest frequency is 25, but that's not our answer. We look for the interclass interval, which replicates the scores. So this is a class interval, and they are a subset of the group data. So this is how we get 20 to 29. Now, what about part 2? State the class interval in which a score of 19.4 would lie. 19.4, where would that lie? In which class interval? Which class interval would that lie? The 19.4. Repeat. All right. I see the question mark. That means you're not so sure.
20 to 29.
29.
All right, why are you saying 20 to 29, Tyrese? Are you saying not sure? Namhard, sorry. You said 10 to 19. Why are you saying those values? Why is it so inconsistent? So 19.4. Which one of the class features will you be using to get to your answer? Which one of the class features will you be using? Which one of the class features? Class features, what is the name? Class feature.
Frequency.
The class features are class limit, class width, class boundaries, class midpoint, and class interval, of course. So remember that this is 19.4. So you use the class boundaries. Yes, the boundaries. So remember that you subtract 0.5 from the lower limit of 10 to give you 9.5. Then you add 0.5 to the 19 to give you 19.5. So where would 19.5 fall?
Sure.
It would fall
10 to
in
19.
the 10 to
10 to
19. 10 to 19.
Sir.
Yes, go ahead.
Can you repeat that, please?
All right, we're using the class boundaries, right?
Yes, sir.
So the class boundaries is halfway, separating halfway. So we have the 10, right? We add the 10, subtract 10 by 0.5. I'm not setting that out properly. I can't necessarily write on the screen.
0.5. Oh, yes, sir.
Yeah, so yeah, subtract 0.5 from 10, and then you add 0.5 to the 19. So this is where the 19.4 term would be. It would be in the 10 to 19 class interval. So for the 20 to 29, the class boundaries would actually be 19.5 to 29.5. And 19.4 is nowhere near that. So this is why it goes into the 10 to 19. All right? So using the class boundaries. So that's why the class features were so important to note. Okay? Okay, everyone?
Yes, sir. Yes, sir.
All right. So now we want to copy and complete. What would be our class midpoint after 14.5? In other words,
24.5.
24.5.
how much?
24.5.
24.5.
Somebody saying
24.5.
24.5. Some people saying 19.5. Which is it?
24.5.
Oh.
And remember, if you said 19.5, check your
Sir.
interval. It's 20 to 29.
Sir.
19.5
Sir,
is not
listen,
even in
listen.
that, right? So remember that you add the lower limit and the upper limit, 20 and 29, then divided by 2. And Tyrese just said you can simply just add 10 to the 14.5. And how did you get that, Tyrese?
I go by 10, sir.
All right, it's going up by 10. But generally speaking, most persons say that they only see a pattern when it is 3 numbers, 3 things being given. So that's what some persons use. Some persons say 2 or more. So yeah.
So if you help on the first 2 number, then we can see them.
Yeah. So that's 24.5. 30 to 39. What would that midpoint be?
34.5.
Okay.
34.5.
And what would the, all right, good. What would the other one be? For the other class interval, 40 to 49, what would be the class midpoint?
44.5.
44.5.
Okay. And 50 to 59?
54.5.
54.5.
All right, Nemhard, you said something. I don't know if you need more clarity as it pertains to the part 2. What was your answer, Nemhard? Why did you say because 19.4 would be rounded down to 19? So it's more closer. What do you mean? Just piggybacking on that. All right. Nothing. All right. I'll have to move on. All right. And we would have calculated our our frequency multiplied by our thingy. Oh, by the way, do we need to find a total for the midpoint? I mean, the space is down here. So can we find a total for our midpoint? Should we find a total for our midpoint? No.
No, sir.
No. we can't find the total for the midpoint.
Of decimal.
Right? Yeah, not because it's a decimal. There's no score. The score is the total, right? So you can't find the midpoint total for this class midpoint. So not because you see this right here being blank, in this scenario, you do not fill this out, all right? You do not add up all of these 4.5 all the way to 54.5. You keep it blank, all right? Because you can't necessarily total class midpoint. So we would have calculated our frequency multiplied by our midpoint. And again, you want to check some of these answers. So the one down here, so 20 multiplied by 44.5, what do you get?
890.
890.
All right, and what's the final one? 54.5 times 12?
654.
654.
All right, good, you're at it with the calculator. So what is the total now of fx?
3,140.
All right, what do I do with that 3,140 as it pertains to finding the mean score?
Divide it by 100.
Okay, lovely. So the sum of the data, 3,140 divided by the number of data points, which is the total frequency, which is 100. And we get 31.4.
Yes.
All right? So pay close attention to the answer that you got, which is 31.4, right? So that's your mean score, okay? Is everybody okay with that?
Yes, sir.
Yeah?
Yes, sir.
All right. Now the standard deviation, the same question, is 6.2. What does the standard deviation of 6.2 tell you about the marks obtained by the children? So the standard deviation was 6.2. Your mean was 31.4. What does this tell you about the student? Can anyone tell me? What do you think the standard deviation of 6.2 tells you about? So technically now, you're not comparing the
They're
6.2.
inconsistent.
Yeah, continue. Yeah, continue. Go ahead. All right.
They're
Yes, I can.
inconsistent.
All right. No, you can't speak of anything about consistency or variation. Are you comparing it to another standard deviation? Yes or no?
No.
No, you're not comparing it to any standard deviation. So no, you can't say anything about consistency or variation. So what do you say? We say that the standard deviation of 6.2 means that the scores generally differ from the mean score of 31.4 by about 6. So that means is that persons might get a difference of 6, meaning if I have 31, let me just run it after 31. You would take 31 from 6. So one person might get 25, right? And another person might add 31 to the 6 and get 37. So that is like your little difference between them, between your mean score that everybody got compared to the scores that you got. All right? So that is what we use, I generally say. So on the syllabus still, it compares a set of values. You have to compare two means. But I just had this question just to stretch your imagination a bit. All right? So standard deviation of 6.2 means that the scores are generally differ from the mean score of 31.4 by about approximately 6. Now, I will leave this question for your homework. So you can all take a screenshot of this question for me, please. Do we all have it?
Yes, sir. Yes.
All right. So I will send an email for you all to send that the working out our question or answer to. All right. So
Yes,
that is where I'll end today's session. But just some summary. The mean and the most common measures of tendencies. The midpoint is used as an estimate of the value in the class interval, which is a group data. The value of your bead can be influenced by extreme values, as you would have seen earlier with the Clark's thing. Remember, when you're doing statistics, you can always arrange your data in order first. To find the mode, ask yourself, what mark occurred most often? What standard deviation means, or SD? It means that the small standard deviation means the data is closer to the mean, while a larger standard deviation means that it is more spread out. So the group with the smallest standard deviation is said to be more consistent. So to find the class boundaries, you subtract 0.5 from the lower limit and add 0.5 to the upper limit. So that is, again, the end of today's session. In the chat, you also have the evaluation form, but on your phones, you can always go onto the camera and go onto this evaluation form. So the evaluation form is crucial to analyzing what we'll be doing next and to see what we can improve on in future presentations to come. So again, thank you all for participating in today's CSEC student workshop on statistics, which is part 1, which was presented by the Region 1 team. So with that, I bid you farewell. And we
not
will...
quite yet, Mr. Lime. Please, we're asking you.